All right, these will be your accuracy and precision notes. Make sure that you take them down, whether you're taking them in a journal or not. So accuracy and precision, whenever we're talking about it from a scientific perspective, accuracy is how close a measured value is to an accepted value, okay? Or sometimes you'll hear it referred to as a true value. Precision is how close a group of measurements, so let's just say a group of measurements, are to one another. Okay, so with accuracy, that's like I know that this weight is 5 pounds, and I'm going to measure it, and I measured it as 4.5. So I was kind of accurate, but not super accurate. Precision is if I am trying to throw goldfish into my friend's mouth. If I make 5 out of 10 of them, I'm not really precise, right? Because I didn't get all of my measurements close to each other. So here is a depiction of that. Most of the time we use targets to depict this. So you'll notice the 4 dots are hitting the bullseye of the target. So not only are the 4 dots hitting the bullseye, which would be the accepted value of a target, but they're also all close together. So we would call this accurate and precise. In the second one, all of the dots are close to each other, but they're not anywhere near the bullseye. So we would say that these are precise, right? Whoever did them got them all really close together, but they're not accurate because they're far away from what the true or accepted value is, which is the bullseye. So not accurate, but they are precise. With the next target, these are all fairly close to the bullseye, but they're not close to each other. Okay, so we would call that accurate, but not precise. And then with the last one, they're just kind of everywhere, not close to each other, not close to the bullseye. So we would say not accurate and not precise. So these are just picture examples. Whenever we're talking about accuracy and precision, we do use this idea of targets to kind of solidify what that looks like. So I would recommend writing these down in your notes. You can use little X's is usually what I use as opposed to dots, just to make sure you know where they are in your notes. So next we talk about error. So error is the difference between an experimental value and an accepted value. So it's a way that we place a number or a value to the concept that we just talked about. So when you're talking about error, it's experimental, whatever the experimental value is. So that's usually whatever has been measured. All right. So if you're reading a problem and it says so-and-so measured this 5-pound weight and they got 4.5 pounds. What they got is that experimental value, and the 5-pound weight, that 5 pounds would have been the accepted. That's what it truly is. Okay. Now, it's not super helpful to talk about error just in terms of this number because we don't know how to compare across different experiments, across different units, things like that. So the most useful way to talk about error is using percent error. Okay, so all that does is it takes that value of error that we just calculated and it expresses it as a percent. Okay, so the percent error, formula is percent error equals the absolute value of error. So that's just what you calculated. So instead of putting that, you could say experimental minus accepted divided by the accepted value times 100. The reason that we say the absolute value of error is because we can't have a negative percent, right? If I say I ate 50% of a pie, you all kind of have an idea of what happened. If I say I ate negative 50% of the pie, y'all are going to look at me like I've been crazy. Okay, so we just say absolute value of error. And anytime we're calculating percent error, we want to make sure that that top step where we go experimental minus accepted is always done first. So if you're putting it in the calculator all at one time, you would do experimental minus accepted and then click enter, get whatever that value is, and then divide it by the accepted value and then multiply by 100 to put it as a percent. Okay? So that's the end of these notes. They're actually really short today. Make sure you go back and watch the 2 practice together videos as we work through these problems, a couple of problems together, so you can see what this looks like whenever it is actually worked through.